Okay, so I'm going to go back over this again, what we went over yesterday. And now looking at this here, we've done this before. Horizontal, vertical translations, vertical stretch, shrink, and reflections. We did this in chapter 1. When we talk about a horizontal translation, it's moving it to the left or the right. We're changing what's inside. Vertical translation, it's moving it up or down. So here, we talked about this the other day. Describe the transformation from x squared, representing by x plus 4 squared minus 1. We have this here. Well, a parentheses x minus h squared plus k. So looking at this here, inside the parentheses, we have what? Plus 4, yes? We have plus 4. Well, what do we have inside here? We have minus h. So the value of h, first off, has to be negative. Because the only way that the sign inside the parentheses can be positive is if h is negative. And the value of h is 4. So what that tells us, since h is 4, it's moving to the left. How far? 4 units. It's moving to the left 4. Now we do have a value of k. K is on the outside, and it would be minus 1. The value of k, how far we move it up or down, really doesn't change too much. Sweet. We're on page 2. Because h inside is kind of the opposite sign. Since it's positive, it's coming out negative. K, on the other hand, just what it is. Since it's minus 1, k is a negative 1. Does a have a value other than 1? Is there a number outside the parentheses other than 1? Well, no. So we don't worry about a. So what that tells us for a is that the graph should not be skinnier, because vertical stretch would make it skinnier, closer together, the sides. Because this here is our parent function. So the distance between these 2 points is not going to change. It'll be pretty much the similar shape. It's just that it's moving left 4 and 1 down. Now, as I said in the video the other day or yesterday, when you, because again, the homework is going to ask for this first. Well, how far did it move? Did it move left, right, up, down? And then it wanted you to pick the correct graph. Which graph does it match up with? Use this thing here. Use this thing here. Because as we saw the other week, if I use the y equals button, I'd hit it, type in the parent function, the function we started with, x squared, in the first one, go down to the second one and type in parentheses x plus 4, close parentheses squared, minus 1, and tell it to graph it. And it'll graph it out, yes? And then what we can do is we can look at the 4 choices that they gave us and figure out which one does it look like, okay? Now, I would do it on the graphing calculator and not on Desmos, because if I ask you to pick which one it is or kind of graph it, you have the ability to do it here. Now, we're not going to do too much graphing on the test, but it is part of the homework assignment, so you can do it that way. It'll tell you what it is. And that's it. That's all we had to do for this one here. Now here, we don't have a value of h, or k, and there's not a value of a other than 1, because a is always going to be 1, at least. It's always going to be at least positive 1. What's the only thing that we have in here? We have the minus 3. Well, so we have ax minus h squared plus k. So h is positive 3, because again, inside the parentheses we have the minus h, x minus h. Here we have x minus 3, so the value of h is positive 3, yes? So it's moving 3 to the right. So the only way it would go up or down is if we had a value of k. but k in our case is 0 because there's nothing added outside those parentheses. There's nothing being added or subtracted. Questions on this here? This here making sense? Yes? Okay. And that's it here. And we would graph it. Again, I would plug it in the graphing calculator to compare the two so you can pick the correct graph. And that's the same thing with these here, is we're just doing that up, down, left, right. Now, I'm not going to go through every example because I think, go through every example in the other video that I already did yesterday. The other one we have here is reflection. Now, if it's outside the parentheses, it's across the x-axis. If it's outside the parentheses, if there's a negative outside the parentheses, it's across the x-axis. If there's a negative inside of the parentheses, it's across the y-axis. Now, across the y-axis really doesn't make a difference if it's still on the y-axis, if it's not away from this y-axis. Because what happens? A negative times a negative is a positive, yes? So unless we have negative x plus 1 or something, a value of h other than 0, it won't make a difference. That's why they have it written there as negative x, so parentheses negative x parentheses squared equals x squared. It doesn't change it. But if we have something other than 0, it won't. We have to leave it that way. There are ways to rewrite it so x is positive, but we're not going to delve into that. Horizontal stretch and shrink, vertical stretch and shrink. Vertical stretch and shrink we've done. We essentially multiply the whole function by it. It's the value of a. The spot where a is will tell if it's a vertical shrink or stretch. Now, the video, if for some reason they didn't get the negative test back to me today, I was going to emphasize this here. So horizontal stretch, yes? Because stretch, we normally think of what? It's a number greater than 1, yes? For horizontal stretch, it's what? Where is less than a is less than. So that means it's a what? Fraction. It's a fraction. And really, the horizontal stretch or shrink, this a value is really equal to b as 1 over a. And you don't have to write this down. And it looks like this here. B comes in front of the x. So if we said it's a horizontal stretch of 3, what we actually plug in here is 1/3. And when it's a horizontal shrink by a factor of 3, we plug in. So here's 1/3, it plugs in 3. When it's a horizontal shrink of 3, we actually plug in, let's see here. So this would be 1/3 plugs in 3. This is 3, we plug in 1/3. It's like the reciprocal of it. It's weird, it's odd, it's strange, we don't deal with it. We're not dealing with it here because, again, it's a flip of what we think it should be. Okay? That's why I don't really delve too far into it and it's not talked about too much. It's pretty much this is what it is, this is how it works, and then we move on. So, describe the transformation of this here. We have two things going on. Well, the value of k is 0. The value of h is 0. I don't have any parentheses, so there's no h value. There's nothing added or subtracted to it, so I don't have an h or k. Both of these are 0 because nothing's being added to it. There's nothing in a set of parentheses that we're adding or subtracting from it. Now, you might be wondering, is that 1/2 a horizontal or vertical? Yes, because the only way that we identify horizontal is if it's in a set of parentheses. So if it had been a closed parenthesis negative 1/2 inside, then it would have been. if the negative 1/2 x had been inside parentheses squared, then we would have been talking about a horizontal stretch by a factor of 2. Because again, it's that flip. It's that flip. It's weird. It's strange. We're not going to worry about it. Now, this here, since it's outside, it means the value of A is 1/2. The value of A is 1/2. It's negative 1/2, but the negative tells me it's a reflection. The negative A tells me it's a reflection across the x-axis. Because A is negative, well, it would be negative 1/2. Since A is negative, it's a reflection across the x-axis. The negative really only tells me if it's a reflection across the x or y. And here it's telling me it's a reflection across the x. The 1/2 tells me it's a vertical what? Shrink by a factor of what? 1/2. The negative tells me it's a reflection across the x-axis, and the 1/2 tells me it's a vertical shrink by a factor of 1/2. Hopefully these here are starting to make a little more sense. It's really, we're just identifying what they are. Questions on this here? And really what that means, that reflection across the x-axis means instead of it going up, it's going to go down. Shrink by 1/2, it's going to be wider. Two x squared in parentheses plus 1. So this one here is not one we did or looked at, because again, that 2 is a horizontal stretch or shrink because it's inside the parentheses. Because it's inside the parentheses. And when it talks about it here, if A is between 0 and 1, it's a horizontal stretch. If A is greater than 1, it's a horizontal shrink. Horizontal shrink by a factor of what? 1/2. Because again, this is why I skipped this part of the section. Because again, it's that flip. It's the flip because it's not really saying it's 2, it's actually 1/2. It's odd, it's strange, it's weird. So this is, again, it's really A parentheses B x minus h squared plus k. That horizontal is kind of what I call B inside there, and what they call A.
So when it's inside the parentheses?
It's like, yes, when it's in, it flips when we talk about the scale. Because even in a later one at S, it says describe or kind of write the transformation when the horizontal shrink by a factor of 3 or 1/3 is this. Well, it's actually inside the problem. When you get finished with it, it's actually 3. They flip it. We have to flip it. And then we go up 1. But we're not going to worry too much about these horizontal stretch or shrink because it doesn't show up too much. Here we have two things going on. The negative tells me what? Across the, what do you think, Eric? Yep. And then we have what, a vertical, Michaela, do you know? Because stretch or shrink? Stretch by a factor of what? Mm-hmm. Stretch by a factor of, vertical stretch by a factor of 3. And that's it. Ta-da. And then we can graph both of those and kind of match it up. Yeah. Now, are there any questions on any of this here, how we've done these? Are we good with this here? Yeah. Okay. I want you to find this here in the notes. So this should be towards the very end. I think it should be pretty much the last page in the note sheet. Yes. Yep. So it's other side of that page. So this form here that I've been rewriting over and over again, a times x minus h squared plus k, is what they call vertex form. The vertex is the minimum or maximum value of the function. So we looked at the graph, the U shape, that bottom of the U, where it goes from decreasing to increasing, is considered the vertex. So when it opens up, that is the lowest point. When it opens down, it's the highest point. And it can be very helpful, and we'll see why, especially when we hit the next section, or next part of the chapter, because the vertex is the h comma k. So the h and k values give us what the vertex is. Now you don't have to rewrite this because essentially it's the same thing. We've been talking about a indicates a reflection in the x and or vertical stretch or shrink. H is a translation, horizontal. K is a vertical. So vertex tells us if it opens up or down and kind of where it starts. Now, that's not too much to be worried about because, again, we've seen that function time and time and time again, yes? Now, what we're looking at, and we're going to do a few problems with this here, is let G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation of 3 units down of this graph. Now, if it is just x squared, we can do a little trick. If it's just x squared, we can do a little trick with this here, okay? I use a cursive little k for up and down.
Okay. I'm sitting here like, okay, I'm paying attention, but that why?
Yeah, because a little k and a capital K on this board look the same. So here, we could do something special since it's just x squared. If it wasn't x squared, we had 2x squared plus 3 or had some other terms. We can't do this. We can only do this because it's just x squared. Because we're transforming this here. And what we're going to do is I'm going to identify A, H, and K. So A is negative. Well, A is our vertical stretch or shrink, so a vertical stretch of 2. And it would be negative because we have a reflection in the x-axis. Because x-axis, A, that value of A, tells us if it's a reflection in the x, and vertical stretch or shrink. Since it's a vertical stretch, the A value would be 2. And it's negative because it's a reflection in the x. We good with everything so far, yes? Followed by a translation of 3 units down. Well, up and down was our K. And since it's down, it would be -3, and our H is 0, because we're not moving it left or right, correct? And again, this only works if the function we're transforming is x squared. So we said what? The value of A was -2. The value of H is? Well, x minus 0 is the same as what? Just x by itself, yes? And that's it. Now, when we just have the function being x squared, that's the only thing that's there, we can use this here. We can plug in A, H, and K and simplify down. And that's the answer. So again, we just have f of x equals x squared. Now what I'm talking about that is if it had been something like this here, 2x squared minus 3x, we can't do the steps we're doing here. But since we just have f of x equals x squared, it's fine to do this. A, H, K. So let's read it. A vertical stretch shrink by a factor of 1/2, followed by a translation of 2 units up. So A is our vertical stretch or shrink and reflections. Well, we don't have any reflections, do we? No, we just have a vertical shrink of, so A is 1/2. H is left and right. Translation 2 units up, nope. And K is positive 2, yes? And that's it. Now we can plug those values in. So A is 1/2 x minus 0 squared plus 2. As we saw this here, x minus 0 squared is just the same thing as x squared. So we just get 1/2 x squared plus 2. And that's it. Any questions on this here? That brings us to the last one. The graph of G is a horizontal shrink by a factor of 1/3 and a reflection in the y-axis followed by a translation 2 units up of the graph of this here. Now A in this case is 1. Because we aren't talking about a vertical stretch or shrink. We're not talking about a reflection in the x-axis. Now, since we talked about this here, this horizontal shrink of 1/3, really, when we plug it into the function, I'm going to call it B, it plugs in as 3. Because again, when we plug it in, it's a flip. It flips from 1/3 to 3. And because there's also a reflection in the y-axis, it is negative. Because there's a reflection in the y-axis, it's negative. I'd pay attention to this problem. So that takes care of the first half, followed by a translation 2 units up. So our value of H is 0, but our value of K is 2. And again, I'm pulling this equation back out because, again, we plugged that value in front of X, that value of B. We're going to plug that value B in front of X. Now, A is 1, so we really don't do anything with it. B is negative 3x minus 0 squared plus 2. Well, the negative 3x minus 0 is just negative 3x squared plus 2. We're not going to drop the parentheses because we still want to identify that there is a reflection in the y-axis. So we can leave it at this here. We could have simplified that to 9x squared plus 2 and got the same thing, but we'll leave it as this here. Any questions on this here? We kind of good with what we did in 2.1, the video yesterday that y'all were supposed to watch. Does this make more sense? Yes? Okay. Well, now you've at least seen it here. And that's it. That's all we're doing.